Good morning, students. And in P block elements, two more groups of elements remaining, and group 17 elements. Now we can discuss about group 17 elements. They are also called halogen. Halogen, the word meaning is salt forming elements. In the previous case, we used the term called chalcogen. Chalcogen means ore forming elements. Fluorine, chlorine, bromine, iodine, and astatine. Fluorine, chlorine, bromine, iodine, and astatine are the members of halogen family. Fluorine, chlorine is in gaseous state. Bromine is the only non-metal which exists in liquid state at all temperature. Iodine is a sublimable solid, and the general characteristics of metal is that it exhibits less stress, but iodine, being a non-metal, that also exhibits less stress property. Astatine is radioactive. Well, as you know, the general outermost configuration of these elements are NS2NP5 and in a particular period these elements possess high electronegativity, ionization enthalpy, etc. That is, the most electronegative element in the periodic table is fluorine, and according to Linus Pauling's electronegativity scale, the value assigned to fluorine atom is 4. That is, electronegativity of fluorine is 4. Electronegativity has no unit. The normal trend in the electronegativity, as we move down the group, electronegativity decreases. And the next step about electron gain enthalpy or electron affinity. Electron affinity is the energy released when a neutral atom picks an electron. When a neutral gaseous atom, say M, which is in gaseous state, picks one electron, it becomes an anion in gaseous state. Some energy is released. That energy is called electron gain enthalpy. This halogens can accommodate one more electron, therefore they possess the largest negative electron gain enthalpy. The largest negative electron gain enthalpy is exhibited by halogens. And this electron gain enthalpy or electron affinity also follows the same trend as that of electronegativity. That is, as we move down the group, electron gain enthalpy or electron affinity decreases. But we can say that here there is slight change in the order of electron gain enthalpy. Electron gain enthalpy of fluorine is less than that of chlorine. This is due to the reason that in fluorine, due to its small size, fluorine, the configuration is 2,7, chlorine is 2,8,7. Here 3 energy levels are there, here 2 energy levels are there. The second energy level, 7 electrons are accommodated in the second energy level, and there arises inter-electronic repulsion between the electron. Here the distance of electrons are somewhat apart because of the large size. That is why electron gain enthalpy of fluorine is less than chlorine. Next, about this reactivity, they are the strongest oxidant or oxidizing agent, and all these elements react with hydrogen to form hydrogen halide. these elements combines with the hydrogen to form hydrogen halide, having the general formula HX. Aqueous solution of this hydrogen halide, aqueous solution of hydrogen halide is called hydrohalic acid. Hydrohalic acid. That is HF, HCl, HBr, HI. Here HF itself called a hydrogen fluoride, and aqueous solution of HF is called hydrofluoric acid. Hydrofluoric acid. This hydrofluoric acid cannot be stored in glass because it reacts with the silicon dioxide. Then can you say among this hydrohalic acid which acts as the strongest acid? As I already told you that fluorine is the most electronegative element. And the force of attraction between hydrogen and other electronegative element is called a hydrogen bond. And here intermolecular hydrogen bond exists. Therefore, hydrogen atom cannot be replaced easily. On the other hand, in HI, the bond between hydrogen and iodine is less, and bond is very weak. Hydrogen or H plus can be easily removed. This is the order of strength of hydrohalic acid. Don't confuse that whether hydrochloric acid is the strongest acid, because we are familiar with that type of acid. And this is the order. As we move across a period, that is HI, HBr, the bond between hydrogen and halogen becomes weaker, and somewhat homolytic cleavage takes place in the case of HI. This is the order of strength of hydrohalic acid. Then halogen combines with alkali metal or S block elements to form their salt. Sodium fluoride, sodium chloride, etc. Ionic, they are ionic compound because alkali metals are electropositive, halides are electronegative in nature. Then halogens can also combine with themselves. That we will discuss later, which is an important compound. That compounds are generally called interhalogen compound. There is a separate topic where we deals with that interhalogen compound. What are interhalogen compound? How are they classified, and what are the different methods for the preparation? Okay. And these elements combines with oxygen. There are different types of oxide formed by this element. Fluorine can form OF2 and O2F2. Among these, OF2 is thermally stable. Chlorine, bromine, iodine, etc. can form different types of oxide, monoxide like Br2O, dioxide, heptoxide, etc. Different types of oxides are formed. And next we discuss about the preparation of chlorine. Preparation of chlorine. Preparation of chlorine. Chlorine was first prepared by the reaction between manganese dioxide. First chlorine was prepared by a scientist called Scheele by the reaction between manganese dioxide and HCl. It gives MnCl2 plus Cl2 plus H2O. MnCl2 plus Cl2 plus H2O. This is the first method. Similarly, it is also prepared by the reaction between potassium permanganate and HCl. Potassium permanganate react with HCl, it gives KCl plus Cl2 plus MnCl2 plus H2O. And on a large scale, this is only small scale production. On a large scale, chlorine is prepared by Dacon's process. Dacon's process. In Dacon's process, oxidation of HCl. HCl undergo oxidation in presence of CuCl2. It gives 2Cl2 plus H2O. Dacon's process. On a large scale, chlorine is prepared by Dacon's process, or it is obtained by the electrolysis of brine solution. Electrolysis of brine solution. Brine means sodium chloride. On electrolysis, this chlorine gas is liberated at the anode. Na plus plus 1 electron gives Na. That reaction takes place at the cathode. Cl minus gives half Cl2 plus 1 electron at the cathode. And the name chlorine is derived from the Greek word chloros. The word meaning of chloros is chloros. The word meaning is greenish yellow. Greenish yellow. That is the word meaning of chloros. And in qualitative analysis, you can conduct experiment in order to identify or detect the presence of chloride ion, where we use this first identification test of chloride is the salt is taken in a dry test tube and you add concentrated sulfuric acid. Then you can see white fumes which turns dense white when a glass rod dipped in ammonium hydroxide is shown to the mouth of the test tube. Okay. Then it is a greenish yellow colored gas, or by adding manganese dioxide, pinch of manganese dioxide, the given salt as well as the concentrated sulfuric acid and the mixture on heating, you can see the evolution of greenish yellow gas. Chlorine is a greenish yellow colored gas with pungent and suffocating odor, smell. Okay, it is slightly soluble in water, that is Cl2 plus H2O gives HCl plus hypochlorous acid, HOCl. It is called a hypochlorous acid. Hypochlorous acid. And in the previous case, HCl is converted to chlorine by Dacon's process by oxidation, and chlorine can be converted to HCl by this method. Sometimes usually I was asked for the examination, how will you convert HCl to chlorine and vice versa? That means chlorine to HCl. And due to the presence of this hypochlorous acid, it decomposes to give HCl plus O. Due to the liberation of this nascent oxygen, as in the case of oxygen, chlorine acts as oxidizing, mainly chlorine acts as an oxidizing as well as a bleaching agent. This nascent oxygen reacts with a colored compound. It gives colorless. Chlorine can also act as a reducing agent also. And next we discuss about the chemical reaction. Chlorine react with excess ammonia. Chlorine react with excess ammonia gives ammonium chloride, NH4Cl, along with the liberation of nitrogen. And the other reaction in which ammonia react with excess chlorine. Ammonia react with excess chlorine it gives NCl3. NCl3, that is nitrogen trichloride, which is an explosive. NCl3 is an explosive. For the examination, you have to write. They do not give the coefficient. NH3 plus chlorine gives. You have to complete the reaction. Or NH3 plus chlorine, within bracket they gives excess. Ammonia react with the excess chlorine. Ammonia react with the excess chlorine gives explosive. Chlorine react with excess ammonia gives ammonium chloride and nitrogen. Similarly, reaction of chlorine react with cold dilute alkali. This one is called dilute alkali. It gives NaCl plus sodium hypochlorite plus H2O. Sodium chloride plus sodium hypochlorite plus HCl. And at the same time, this chlorine react with hot concentrated alkali. Hot concentrated alkali, it gives NaCl plus NaClO3 plus H2O. NaClO3 plus H2O. This is sodium hypochlorite. Hypochlorite. This one is sodium chlorate. This is also important for the examination. That is chlorine, cold dilute, chlorine, hot concentrated, sodium chloride. With a cold dilute alkali, it gives hypochlorite. With a hot concentrated, it gives chlorate. These are the important reactions of chlorine. And also, when chlorine is passed through dry slaked lime, CaOH twice. Chlorine is passed through dry slaked lime, it gives CaOCl2. CaOCl2. Actually, that product form is called bleaching powder. It is called bleaching powder. Chlorine, that is when chlorine gas is passed over dry slaked lime, the product form is bleaching powder. The actual composition of bleaching powder is CaOCl2 dot CaCl2 dot CaOH twice dot 2H2O. This is the actual structure of bleaching powder. For the time being, you just remember it as CaOCl2. And how does it act as bleaching agent? That is CaOCl2 decomposes to give Ca2 plus plus, Cl minus plus, OCl minus. This OCl minus is called a hypochlorite ion, which releases nascent oxygen. Therefore, it acts as bleaching agent. Okay. Next, normally chlorine react with mineral acid such as HCl, H2SO4. All the chlorine present in the bleaching powder is liberated. That liberated chlorine is called available chlorine. Bleaching powder react with the mineral acid, then all the chlorine present in the bleaching powder is liberated, and that chlorine liberated is called available chlorine. A good sample of bleaching powder contains 38 to 39% of this available chlorine. For your scientific project, that also included as a part of the syllabus. In addition to practical, you have to conduct some innovative project also. You can find out or take it as a topic for finding the amount of available chlorine for a sample of bleaching powder. And the important uses of chlorine. Chlorine acts as oxidizing, bleaching as well as reducing agent. Then second one, it is used for the preparation of bleaching powder. Used for the preparation of bleaching powder. And chlorine is used for the production of toxic gas such as phosgene. Phosgene is carbonyl chloride, COCl2, mustard gas, Cl, CH2, CH2S, CH2, CH2Cl. This toxic or poisonous gas is used by Adolf Hitler during the Second World War. And also tear gas. Tear gas is CCl3NO2. All these are examples for toxic gas. This is also used for making HCl also. HCl. And you just go through about HCl. HCl is prepared by the reaction between sodium sulfate or sodium chloride with the sulfuric acid. NaCl plus H2SO4 gives NaHSO4 plus HCl. Then NaCl plus NaHSO4 gives, this is about 420 Kelvin, and at 823 Kelvin it gives Na2SO4 plus HCl. Okay, that's about preparation of HCl. Then oxides and oxo acids, that is not included, but even though if you want to write the oxidation property, I just mentioned the oxo acid of chlorine. Oxo acids of chlorine. And here the oxo acid of chlorine. Chlorine mainly forms 4 types of acid. That is, first one is hypochlorous acid. Hypochlorous acid, HOCl. HOCl. Second one is chlorous acid. Chlorous acid, HClO2. HClO2. That is chlorous acid. And the third one is chloric acid. Chloric acid. Chloric acid, HClO3. HClO3. Then fourth one is perchloric acid. Perchloric acid. Fourth one, perchloric acid, HClO4. HClO4. The strength of oxo acids, that is HOCl is hypochlorous acid, HClO is chlorous acid, HClO2 O3 is chloric acid, and HClO4 is perchloric acid. And the strength of oxo acids increases in the order HClO, HClO2, HClO3, HClO4. Perchloric acid is the strongest oxo acid of chlorine. And next is the important area, that is about interhalogen compound. Interhalogen compound. Interhalogen compound means halogens combines themselves to form interhalogen compound. Halogen combines themselves to form interhalogen compound, but all such compounds not belongs to the class of interhalogen compound. For example, these interhalogen compounds are mainly divided into AX group, AX3, AX5 and AX7. Then here A is a larger halogen, X is a smaller halogen. A have larger size and X have smaller size. As we know, as we move down the group, size of the atom increases. As the size of the atom increases, you can compare which one is have larger size. For example, if you merely study that interhalogen compounds are compounds formed by the reaction between halogens, and once the question asks like this, FCl is an interhalogen compound, that statement is wrong. Actually, FCl is formed by the reaction between fluorine and chlorine, both are halogens. But if it is a interhalogen compound, this is in the form AX. Here A is fluorine. Fluorine has smaller size and chlorine has larger size. This is wrong. This is not an interhalogen compound. ClF is an interhalogen compound. BrF is an interhalogen compound. BrCl is an interhalogen compound. AX3, BrF3, ICl3, all these are interhalogen compound. They have the shape usually asked for the examination, that is T shape. T shape. That is ClFFF. T shape. BrF3, ICl3, T shape. This is ClF5, that is very rare, mainly IF5. Here also IF7. These are the examples for interhalogen compound. What are interhalogen compound? How are they classified? Interhalogen compounds are obtained by the reaction between halogens, and they are mainly belongs to this group. Here A is a larger halogen and X is a smaller halogen. And one more point, these interhalogen compounds are more reactive than corresponding halogen. For example, ClF3 is or ClF is more reactive than F2 or Cl2. This is because Cl-Cl bond is stronger than ClF bond, or ClF bond is weaker than Cl-Cl bond. As easily that bond breaks and it undergo reaction readily. And interhalogen compounds are formed by the combination of halogen under different conditions, and they are used as fluorinating agent in the enrichment of uranium hexafluoride UF6 plus 3 ClF. Uranium hexafluoride is used as a nuclear fuel, enrichment of uranium. That's about interhalogen compound. Interhalogen compounds are formed by the reaction between halogens, and all these compounds are not belongs to interhalogen compound. They are mainly divided into this 4 category. Here AX, AX3, AX5 and AX7. A has larger size, X has smaller size. And if question asked like this, say water is the largest source of halogen. Seawater is the largest source of halogen. Comment on the statement. You know, seawater contains elements such as sodium, potassium, calcium, magnesium, etc. They are found as their iodide, chloride, nitrate, sulfate, etc. And mainly sodium chloride is the seaweeds. They contains iodine and bromine, sodium bromide to a certain extent, or in that sense sodium seawater is the largest source of halogens. Okay, that is about group 17 of the periodic table. Next we discuss about the last group. Last group of element is 18th group. Group 18 of the periodic table. 18th group elements. 18th group elements are called noble gas or inert gas. Noble gas or inert gas. The members of that family: helium, neon, argon, krypton, xenon and radon. Except helium, all other metals, all other elements have the stable configuration, NS2 NP6 configuration. Due to that stable configuration, they show less affinity towards chemical reaction, or in other words, they are chemically inert or less reactive. That is why group 18 elements are called noble gas. And first we discuss about the different types of or properties of these elements. They have completely filled electronic configuration or complete their octet. There is no chance to accommodate any more electron. Therefore, they have positive electron gain enthalpy. The solubility of these elements increases from helium to zinc or helium to radon. The solubility increases. The melting point and boiling point increases down a group. Because weak van der Waals force exists, the melting and boiling point increases down a group. And the uses of noble gas. Helium is used. It is used as, that is in Henry's law we have studied that helium is used as a diluent for air. The tank carried by scuba divers, they contains air diluted with the helium to prevent the toxic effect of nitrogen. Okay, it is used as a diluent for air, especially the tank carried by scuba divers. Helium is used for study the mechanism of reaction takes place at very low temperature, or they are used in cryogenic study. Helium is used to produce and sustain superconducting magnet in NMR spectroscopy, nuclear magnetic resonance spectroscopy. Spectroscopy is a branch which is used to elucidate the structure of complex organic molecules. Not only organic molecules, complex compound. That branch is called spectroscopy. Atomic mass spectroscopy is the Raman spectroscopy, is the UV spectroscopy. This is nuclear magnetic resonance spectroscopy. And similarly, helium has a great influence for producing superconducting magnet in magnetic resonance imaging system for clinical diagnosis. That is MRI scanning system for producing. Normally 1.5 Tesla power, magnetic power is used, and mainly helium is used for that. And also it is used for filling airships or balloon. Next about neon. Neon is used for advertising purpose, for filling bulbs, especially for this advertising purpose. Then argon. Argon is used to produce inert atmosphere in extraction of metal, or inert atmosphere in metallurgical operations. Inert atmosphere. Then krypton and xenon is used in the flash bulb of high speed photography. Flash bulb of high speed photography. And finally radon, being radioactive, it finds application in medicinal purpose. This is about the uses of this noble gas. Okay, and as we already told that except helium, all other elements complete the octet, and in one word we can say that elements are chemically inert because of the stable octet. But you can see that xenon, that is helium, neon, argon, krypton, xenon and radon. Among the completely stable configuration element, xenon is little bit of reactive. Definitely there should be some reason for exhibiting the high reactivity of xenon. The reason is that a scientist called Bartlett found that the ionization potential or ionization enthalpy of xenon is almost, this is about 1170 kilojoule per mole. Xenon is almost similar to that of dioxygen. Ionization enthalpy of xenon is almost equal to dioxygen. Therefore, xenon react with oxygen as well as highly electronegative elements such as fluorine to form the respective compound. The high reactivity of xenon is why question asked like this: even though these elements are termed as noble gas, xenon is highly reactive. How will you account for this? The reason is that, the answer for the question is that xenon, ionization enthalpy of xenon is almost, not exactly equal, almost similar to that of dioxygen. Oxygen combines with the fluorine, O2PtF6. Similarly, the first noble gas compound prepared is XIPtF6. This is the first noble gas compound prepared. Already O2PtF6 exists, and because of the comparable ionization enthalpy, this XIPtF6 is the first noble gas compound prepared. Okay, next xenon react with the fluorine as well as oxygen form fluoride as well as oxide and oxyfluoride under different conditions, and we have studied in detail about the preparation, their geometry as well as the hybridization of xenon in all this compound. That we'll discuss in the next class. Okay, thank you.